this video, we're talking about completing the square, which is a method that we can use to solve for the roots or the solutions of a trinomial, even when we can't factor that trinomial. And this kind of builds on our knowledge of zero theorem. And remember, the zero theorem told us that if we had some trinomial, like for example, x squared plus 5x minus 6 equal to 0, we could factor it, so we'd get x plus 6 times x minus 1 equal to 0, and then we could set each factor equal to 0 individually. So we'd say x plus 6 equals 0 and x minus 1 equals 0. And then we'd solve these individually. We'd subtract 6 from both sides of this first one, and we'd get x is equal to negative 6, or solve this second one, add 1 to both sides, and get x is equal to positive 1. And now we know, using the zero theorem, that the solutions to this trinomial equation are x equals negative 6 and x equals 1. These are the two values of x that will make this equation true. But what happens when we're given a trinomial equation where we need to find the roots, just like we did here? We need to find these roots, but we can't factor the trinomial on the left-hand side. If we look at this one here where we have x squared plus 10x plus 6, there are no factors of 6 that'll give us 10. So the factors of 6 would be 6 and 1, 2 and 3. There's no combination of 6 and 1 or 2 and 3 that'll get us to 10. So how do we go about finding the roots? Well, one method we can use is called completing the square. And when we complete the square, what we do essentially is create a perfect square on the left-hand side so that we can take the square root of that perfect square to solve for x. So here's how we do it. We follow the same process every time for completing the square, and it's always going to work as long as you have a trinomial on the left that's equal to 0 on the right. So the first thing we want to do is move this constant. Here we have a positive 6. We want to move that over to the left-hand side, and we'll do that by subtracting 6 from both sides. So if we subtract 6 from both sides, obviously on the left-hand side, they're going to cancel. A positive 6 and a negative 6 will get 0. So we'll just be left with x squared plus 10x. And on the right-hand side, 0 plus a negative 6, or 0 minus 6, gives us negative 6. Now we're going to take the value, the coefficient, in front of our first degree x term. So we have x to the second, we have x to the first. We're looking at our first degree x term, the one with x to the first, and we're going to take the coefficient, whatever's in front of that. We're going to follow this process every time. We're going to divide that value by 2, so 10 divided by 2, and then we're going to square the result. So now we just follow our order of operations. We do the parentheses first, so 10 divided by 2 is 5, so that's going to give us 5 squared, and now we do our exponents. 5 squared we know is 25. So the result there is 25, and 25 is the number that we can add to the left-hand side to make this a perfect square. So now we're going to essentially add 25 to both sides, and when we do that, we're going to get x squared plus 10x plus 25 on the left, and then on the right, negative 6 plus 25, or 25 minus 6, either way, we get 19. Now, the 25 makes the left-hand side a perfect square, so we should be able to factor the left-hand side. If we look at the factors of 25, we know that 25 is 5 times 5, and we can use two positive 5s to get to a positive 10. So we get x plus 5 times x plus 5 is equal to 19. Now, a couple things to note about completing the square. If you've done this correctly, you should get two identical factors. You'll never get two factors that are different. In this case, we got x plus 5 times x plus 5. Those factors are the same, and they always will be if you've completed the square correctly. Also, the factor that you're going to use, in this case we used 5, right? This factor comes directly from this value right here, or this value right here, 10 over 2. So really you're just taking this original 10 that you pulled out, the coefficient on the first degree x term, and you're dividing it by 2. And whatever that is divided by 2, that's the factor you're going to use. So you can just plug that factor in directly. You should have two of those factors, and if you FOIL this back out, if you multiply this back out, you should get to x squared plus 10x plus 25. So now we have these two factors together, and we can rewrite this as x plus 5 squared, because we have two x plus 5 factors multiplied together. We can call it quantity x plus 5 squared equal to 19. Now remember, we're trying to solve for x just like we did when we used zero theorem. And in order to solve for x, we have to get this x by itself. So our first step is going to be to take the square root of both sides. So we'll take the square root of both sides. And when we take the square root of x plus 5 squared, the squared here is going to go away. So the square root and this exponent essentially cancel each other out, and we're just left with x plus 5 equals, now this part is important, positive or negative root 19. So positive or negative square root 19. Because we're taking the square root, we have to remember to include this positive or negative sign. Now we just subtract 5 from both sides to solve for x. So we get x is equal to negative 5 plus or minus square root 19. So these are the solutions to our trinomial equation here. If we want to write them out separately, we can say x is equal to negative 5 plus square root of 19, and x is equal to negative 5 minus square root of 19. These are our two solutions. Now let's look at a second example here. We have x squared minus 9 is equal to negative 7x. The first thing we want to do is get this negative 7x over here onto the left-hand side with this x squared term. So in order to do that, we're going to add 7x to both sides, so plus 7x. And when we do that, we'll get x squared plus 7x minus 9 is equal to 0 because we get these two to cancel. Now we want to move the negative 9 over to the right, so we'll add 9 to both sides. And when we do that, we'll get x squared plus 7x. These two will cancel, and we'll be left with positive 9 over here on the right. Now, remember, we're following the same process we did in this first example. We're going to take the coefficient on our first degree x term here, which is 7, and we're going to say 7 divided by 2, and then square the result. We can't reduce the fraction 7 over 2, so we just square it, and we get 49 over 4. This is what we need to add to both sides to make a perfect square on the left, so we're going to say plus 49 over 4 and plus 49 over 4, and we get x squared plus 7x plus 49 over 4. And on the right-hand side, we have 9 plus 49 over 4. Now, if we've done this correctly, we should be able to factor the left-hand side as a perfect square. So remember, we're just going to take this value we found here, and that should be the value we plug into our factor. So we're going to get x plus 7 halves times x plus 7 halves. And if we FOIL this back out, we should get back to this answer, and in fact we do, because x times x gives us x squared plus 7 halves x plus 7 halves x is plus 14 halves, or plus 7x, and then 7 halves times 7 halves gives us 49 fourths. Over here on the right, we have essentially 9 over 1. If we want to find a common denominator with 49 over 4, we need to multiply this 9 over 1 by 4 over 4. So 9 times 4 is going to give us 36. 1 times 4 is going to give us 4, and now we have 36 over 4 plus 49 over 4. So when we combine those, because we have a common denominator, 36 plus 49 is 85, so we have 85 over 4. Now we can go ahead and rewrite this as quantity x plus 7 halves squared, because we have two of the factors. It's a perfect square, so quantity x plus 7 halves squared is equal to 85 over 4. We want to solve for x, which means we need to take the square root of both sides. See how we're following the same process we did before? Taking the square root of a square gets us to cancel those, and we're left with x plus 7 halves. And over here on the right, we get positive or negative root 85 over 2. And the reason is because we have this positive or negative always when we take the square root, just like we had it over here on the square root 19. When we take a square root of a fraction, remember we can take the square root of the numerator and the denominator separately. The square root of our denominator 4 is 2. The square root of 4 is 2. So we can pull that outside of the square root, no problem. But the square root of 85, we can't simplify at all. If you try to factor 85, you can't find any perfect squares inside of it. So 85 is simplified as much as possible, and we're just going to have to leave it as the square root of 85. Now, in order to solve for x, we'll subtract 7 halves from both sides, and we'll get x is equal to negative 7 halves plus or minus root 85 over 2. Before we call this our final answer, though, what we want to notice is that we have this common denominator of 2 in both of our fractions on the right-hand side, so we can combine these into one fraction and say that our solutions are x equals negative 7 plus or minus root 85 all over 2. So now we have one fraction. And if we want to write out both solutions, we'll say x equals negative 7 plus root 85 over 2, and x equals negative 7 minus root 85 over 2. And those are the two solutions to our trinomial equation, which we found by completing the square.